the electricity is used in our home. First of all, we need to understand that one. So we have a switchboard in our home. We're just pressing that one. It makes your light to on or your TV to on, a fan to on, all the things. What happens inside and how the connections are working there. If any one wire cut inside of it, your light will not turn. So if it is so, what you will do, you will just call the electrician to make it to be corrected, right? So what they are doing and what the correct connection was there, that we are going to understand here. Okay, so what are things you're going to learn today was like we are going to make a very interesting project with the ordinary board, or as always. And here we'll be understanding that how to connect the LEDs in serial and parallel manners. Okay, and we are going to get the information about what is electrical circuits is. So electrical circuits are essential for understanding how electricity flows. So already we know that what is electricity. First of all, we need to know that what is current is. So current is nothing but the flow of electrons. So flow of electrons means where the electrons comes from. The electrons comes from the atom. Okay, so atom is an indivisible particle which is made up of three subatomic particles, that is the proton, electron, neutron. So proton is positively charged particle, electron is negatively charged particle, neutron is neutral, that is no charge, right? So the electrons will be in the outermost shell and the proton and neutron will be on the innermost shell. So electron, what will happen was if you give some force on that, it will start to move from one place to another. The movement of electron is said to be a current, right? So how the current, what is voltages? So if somebody in your home, if your lights was blinking, your mama will, papa will tell you that please off the light. The voltage is dropped. Why are they telling that? So what is voltage here? What it means to turn on the LED or lights over there? You knew about it? No, right? Fine. So now, voltage is nothing but the potential difference between the 2 points, or we in simple way we can call it is a pushing force. Okay, how fast the electron is pushed, the current will pass that much faster. Okay, so if sometime it will be there's a block and flow of electrons, so that your current will be likely moving. So on that cases only your voltage got be blocked and your lights are flickers, right? So yeah, current, voltage, this is the two things. So current is nothing but it's a flow of electron. Voltage is nothing but it's a potential difference between 2 points or a pushing force in simple way. All right. And if in your home there is no power, so why we used to call power there? We supposed to tell the current only, na? Why current off? Like that only you supposed to ask me, right? But we are asking power off or power shut on in my area, like that you are telling. So what is that power is? Actually, power is nothing but the current and the voltage. Okay, it is nothing but it is a current and voltage. Multiplication of current and voltage is called power. That is simple. Okay, that's what we are telling, power. So power means in watts only we will be measuring that one. Power is measured in watts, whereas current is measured in amps, whereas your voltage is measured in volt. If you're going to shop to buy a small bulb or light, what you will tell? You just asking them. Of example, you'll be asking, sir, give me a 0 watts bulb or 50 watts bulb. Even though whenever you're buying some electronics item or any items in your home, you can check the backside of it, like what the volts it consumes and the ampere it consumes, like that. All right. So serial and parallel connections are the fundamental to circuit designs. First of all, that's what we are going to understand, and we are going to do the project with that one. Okay, so what is electrical circuit is? An electric circuit is a path that allows electric current to flow and which enables the energy to be transferred from the source to the load. All right. So there are three main parts of that. Okay, one will be components of that. One will be your power source, conductor, load. a switch is an it's a side of it, right? So when you on the switch, the current should be flow. That's it. Switch, nothing you want to deal with, but the three are the basic components, that is power source, conductor, load. All right. The power source nothing but which provides the energy to the electrons which moves. Okay. Whereas the conductor means, we know that there are three types of materials there: conductor, semiconductor, insulator. Conductor, which allows the current to pass through it. Okay. Semiconductor, which partially allows the current to pass through it. Whereas inductor, which doesn't allow the current to pass through it. Example of conductor, we call all the metals, right? Okay. Example of insulator, wood, plastic, glass. Whereas example of the semiconductor, aluminum, like that. Okay. If you have any queries, you can ask me in between also. Okay, there are two types of electrical circuits are there. One is serial circuit and the one is parallel circuit. In serial circuit, components are connected in a single path. So the current flow will flow through each component will be same only. Okay. And whereas the circuit, parallel circuit, components are connected along the multiple paths, allowing the current to flow through different branches. All right. So example, as a simple circuit, a battery, wires, a switch, and the light bulb connected in a closed loop. I show you that how it will be works in a small example. Just take you to Tinkercad. All right. Circuits. Just taking a breadboard, LED. Three LEDs I'm going to use now. Now I'm going to show you the connection without audio. So three LEDs. One, here, three here. All right. So I'm going to make the GNDs to be common. So yes, GNDs. All the cathodes I'm going to connect to the common parallel. So I'm going to use battery. So all the negative pins are connected in a single place. Okay, so just take the negative and connect it over here. Now all the positive should be connected to the same line. See now, all will get the same amount of current while it is moving on. Okay, so see here, if I remove the connection from this, all the other will glow, only one will off in parallel connection. Whereas in series, if any one connection is left, it will stop the current flow. Okay, this is a parallel. Okay, I will just show you the serial also now. So serial means it will be connected one after one. That is, this resistor will be connected to the. Now I have connected the resistor positive to the LED positive to the resistor one end of the resistor end, and then the second LED is negative to that resistor first end. Okay, and then the second resistor should be connected to the LED's positive end, and third LED should be connected to the second resistor another end, and the positive of the LED should be connected to the third resistors first. Okay, so this is my cathode. So cathode should be connected to the negative, that is GND. Right, and this is my anode. Anode should be connected to the positive. You see now. Okay, now see this. I'm going to take the resistor in from here. See what happens. No LED will turn on because there is not a closed loop. Only the closed loop, the current flow will be there. It is not a closed loop. Now it is open loop. So the current is not flowing in it. This is what the serial connection. Whereas in parallel, all the ends are connected to the same point. So the voltage will be same for all the LEDs. Whereas here, the current will be same and the voltage will be different. So that the power will be not transfer from one LED to the another. Give me a minute. Let me share my screen again. Okay. Yeah. Why are circuits important? Circuits are the foundation of all electrical and electronic devices. Okay, that's what we need to understand about what is a circuit and how to make the connections at all. Okay, they enable the transfer and use of electrical energy for various purposes. Understanding the circuit is essential for electrical engineers and anyone working with electrical system. Right. So the components we are going to use in this session's visit, Arduino, LEDs, resistors, jumper wires, power supplies. So power supply we are going to use through battery, or we can use through the USB cable. So yeah, I'll show you the LED connections and what is LED now, how the connection has to be done in practical. Yeah, so I'm going to use Arduino here again. So now we are going to make traffic light system, Diwali light patterns, and we are going to generate some of the interesting light patterns now. Okay. First, I'll just show you how to make a traffic light system. So this is the Arduino Uno board. Arduino Uno board is a microcontroller which allows the beginner to start with the robotics journey. Why we are using this was it is open source. Anyone can use this, and the features in this was very simple and easy to understand, and the coding also very simple. Okay, it has totally the 14 digital pin that start from 0 to 13. Okay, totally 14 digital pins will be there, and analog pins are 6 from A0 to A5. A0, A1, A2, A3, A4, and A5. There will be 3 GNDs. Here's one GND, another one, and another one over here. And VIN pin, we can power our Arduino in 3 ways. One using the VIN pin, another one using the external power source, and another by through USB cable. And you have a reset button over here. This is the microcontroller. The name of the microcontroller was Atmega 328 microcontroller. All right. So the 13th pin is an inbuilt LED. This is an inbuilt LED. You can see the L over here. This is the inbuilt LED. Okay. Whenever you want to on the inbuilt LED, you should turn on this 13th pin. Okay. The 0th and 1st pin is especially for transmitter and receiver things. When you're using any communication devices, we'll be using the 0 and 1 pin, right? Okay. So first, we are going to make the project called traffic light system. All right. So traffic light system means what? So you all might saw the traffic lights. You all might be stuck on the traffic lights in your life. So while you're waiting, you might saw three different colors over there, right? So there'll be a red, green, and orange. What is red, green, and orange? What it indicates actually? So red means stop, obvious. Green means go, and orange means get ready, right? Same thing. Here we are going to use three LEDs. So first red, and then I'm going to change the color of the LED to be orange, and this one green. Same three resistor. So I'm connecting all the resistor to the better I went to the connection over here. So I'm going to make use of the common negative. Take a GND, connect to the CLA. So yeah, this also allows you to understand the parallel and serial connection which is in there in your breadboard. So if I connect any positive or any pins over here, the whole line will get positive. This is an vertical one, and a horizontal one, it's a series connection. So series connection, if you connect any positive to here, this whole line will get the positive connection. All right. So yeah, then the first pin I'm going to connect to pin number 2. And pin to pin number 3. Third pin to pin number 4. So forever, it has to do continuously, so that I'm keeping forever here. And then output, in output, set digital pin number 0 to be high. Here I need to change as 2. 2 is red. Red should be on for 1 second. Go to delay. 1 second. Output 2. Sorry, 3 high, and wait. 4 high, and wait. So see what happens now. See, all the lights are turning on, right? So, but I don't want like this, right? So, how the parallel light, I mean, C light will be, your traffic light will be there. First, the red will glow, then the orange will start, and then the green will be. So, what you're supposed to do is first it will start to glow, and then pin number 2 should be on. Pin 2, and wait. Three should be low, and wait. Then 4 should be low, and wait. Run on, off, red, and the yellow will on off, and then your green will turn on and turn off. Is this clear? Any doubts you have till now? Any doubts? If you have, you can just ask me. Hope there's no doubts. All right. So all about the traffic light system. So here you can check the voltage of the lights. Okay, voltage of the LED which is um you can find the component called multimeter. So multimeter is a device which is used to measure the multiple parameters. Some of the parameters here there is like temperature, sorry, voltage, current, insulations, inductance, and all these things we can measure. Negative should be connected to negative. Positive or validity should be connected to the positive. The first will be 0. See, it got 2.9 V. Am I right? So now I said you that in parallel serial connection there's a voltage difference, so that your LED will be stop working when you remove from the serial connection, right? And then I just show you there also how the voltage will be. First, I go with the serial parallel connection. Then I'll go with my series connections. So G and D is negative, and all the positive should be connected to the same. In the 5V. So all the LEDs are turning on now. So keep 5V to this place. 5V on the positive lane and negative on the G. See, all the three LEDs are getting 5V here. So voltage will be same, current will be differ in this, I mean in this connection, parallel connection. So voltage is 5V now. See the current ampere. 25 amps. Whereas I check this to this one. Voltage. Okay. So now I'm going to show you series connection. So series connection means the resistor will be connected to one another, one to the another end. So positive, negative, negative, positive. If you have any doubts, you can ask me at the same time. Okay. empty and the positive negative to the negative. Positive to the first LED. 1.6. Put this on second LED, what happens? Let me check that. There it is 1.6. Now it is 3.31. Keep this on the last one. It is 4.98. All right. Any doubts? No doubts, right? All right. So voltage will be differs over here. Current will be constant. I'll show you how the current will be constant. So it is 5 milliamps. All right. I'm going to change the position of this to be here. It will be 1.58 milliamps. If you measure in a regular multimeter, it will be same. So now we are going to do a second activity. So first activity will be a traffic light system. Second activity will be Diwali light patterns. Okay. So here I'm going to connect 5 LEDs. One, two. 3, 4. If you want, you can change the color of the LEDs also, but I'm not going to change the color of it. So all the negative, I'm going to make it as a common over here. And the positive should be on the first pin to the pin number 2. Second to the pin number 3. Third to pin number 4. Pin number 5. And 6 to pin number, sorry, 5 to pin number 6. All right. Yeah. Now we are going to make a pattern. First, if you wanted to on all LED, what you're supposed to do? Just bring all the blocks like 5, 1, 3, 4, 5. So 2, 3, 4, 5, and 6. For the control in that weight block, you need to drag and drop, and you need to duplicate this one again, attach it, and make all the highs to be low. That's it. So now all the LED will off the time. You know one thing why this flashing light shows here? It's because the over voltage. So what you're supposed to do is you're supposed to use the resistor. So yeah, I'm going to use a resistor instead of this. The resistor turning on or the resistor going. So as I told you, we wanted to create um patterns here. How could you create a patterns? That we are going to see. And before that, I'll show you how to do the coding in Textcode. So in previous session itself, we understand that what is void setup and void loop. In void setup, what are the function you wanted to give for it to initialize? We can give it over here. What are the commands you want to give it to do continuously? We're supposed to give it inside the void setup. Sorry, void loop. So I have attached file is now as of now. In I'm going to keep each LED a different name. Okay, you should not give the same variable for all the LEDs. If you give so, the program will get confused. It doesn't know when you turn on the first LED, second LED by its own. Okay, we should give clear information to the machine to perform the work as you wish. LED is equal to LED1 is equal to 2. First LED is current pin number 2. Int LED 3. Sorry, 2 is equal to 3. Int LED 3 to 4. Int LED 4 to 5. Int LED 5 to 6. All right. And then pin mode we need to define. I think M should be capital, other should be small letter. Pin mode 2, comma output. Our devices, output devices which we are connected. So we need to give output. If you're using any sensors, on that cases we have to give in. Pin mode 3, comma pin mode comma out. Pin mode 6, comma output. All right. So once you define, we need to make it to on and off. Okay. So for owning the LED, we're supposed to write the command called digital write. Digital write 2, comma 5. Right. So we call digital write 3, comma 5. Digital write 4, comma 5. Digital write 5, comma 5. Digital write 6, comma. Okay. And So I'm giving 2 seconds. 2 seconds on. 2 seconds. Copy this and paste it again and make all the highs to be filled. Sorry, pin no. So all that is are turning for 2 seconds and going off for 2 seconds. On for 2 seconds, off for once, out of 2 seconds. Okay. If I wanted to make a little pattern, okay, it should be a running LED. So what I supposed to do is we'll off all the odd numbers and even numbers like that. Okay, so first odd numbers 2, 1, 3, and 5. So first LED high, second should be low, third should be high, fourth should be low, five is high. All right, here it should be a vice versa. So first should be low, and second LED should be high, third should be low, should be it's not looking like a moving LED, right? So what you're supposed to do is you're supposed to reduce the delay here. So if you give instead of 2000, it's 200. See how it works. We give 500 little high. Like this, we are going to create a big pattern now. So I'm going to attach 3 more LEDs along with this. So 1, 2, and negative. I'm going to use a resistor. So LED number 6 to 7, number 7 to 8, and 8 to 9. And 6 is equal to 7. LED 7 is equal to 8. LED 8 is equal to 9. Your pin mode 7, comma output pin mode 8, comma output pin mode 9. here again I need to add the values here, right? So digital, right? 7 comma low. Digital, right? 8 comma high. Digital, right? 9 comma low. So and paste over here. So low to be high, high to be high. High. Out still now. If you have any queries, you can post on chat box or you can ask me. No doubts? You can see the output. You can make more cascades like this and more casting like this. We can make arrangement of our first letters also, and we can create it to both categories. I'll show you now. So even more funnier we can make it. It should be running like little time to initialize. Just see how legs are going. I can make it to 300. You are friends now. So we create a left. The serial using that only will be great.